Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we're going to be talking about some triangle application theorems, and I'm also going to add some extra polygon theorems. We're going to start learning about polygons in general today. And in this chapter is kind of like a prelude or a prequel to actual polygons and learning about their angle measures and exterior angle measures, how to find them, all that good stuff. So it's actually quite fun. This, I think, is part of the enjoyment part of this book. So let's start right off the bat. Triangle sum theorem. The triangle sum theorem states the following. The interior angle sum of any triangle equals 180. Wait a second, Mr. Morrow. Didn't we already do this? Yes, we did. You know this already. Regardless of the triangle, the interior angle sum will be 180. How does that help me? Helps me a lot. If I've got 40 and then this is 70 and this is x, well, I know that x plus 110 has to equal 180. So x would equal 70. How does that help me? What kind of a triangle is this now? An isosceles triangle. So that means this guy is congruent to that guy. Excellent. Great job. So the sum of any triangle, it doesn't matter what kind of a triangle it is always going to be 180 degrees. Okay? Always. Number two, the interior angle sum formula for any polygon. I'm actually going ahead. This is part of 7.2, but I just wanted to do it. To find the interior angle sum of any polygon is n minus 2 in parentheses times 180, where n is the number of sides of the polygon. Okay? Did we go over already what a regular polygon is? What is a regular polygon then? Okay, good job. A regular polygon is a polygon where all angles and all sides are equal. This formula works for regular polygons or non-regular polygons. So let's say I want to find, let's prove this. Triangle. How many sides does a triangle have? So 3 minus 2 times 180. That equals 1 times 180, so there's 180 degrees total sum of a triangle. How about a pentagon? Pentagon has 5 sides. 5 minus 2 times 180, that's 3 times 180, which would be 540 total degrees inside of a pentagon. It does not matter how many sides the polygon has. It does not matter if the sides are equal or not. If you want to find the interior angle sum, okay, of any polygon, it's in parentheses n minus 2 times 180. Okay? Now, another theorem that we have already learned as well, okay, it's called the exterior angle theorem. And we learned this exterior angle theorem already. We did this once before when we were learning about triangle inequalities. So let's see if our memories serve us correctly. Which do you think here, gentlemen, would be the exterior angle? 1, absolutely. Why would that be the exterior angle, Morrow? Because it is outside of the triangle. That's the exterior angle. Do you guys remember what the remote interior angles would be? Yes, sir. It'd be 3 and 2. Very good. 2 and 3. And well put. Good job. Good memory. It is the complete opposite side on the interior of the exterior angle. So this guy and this guy would be the remote interior angles. And which one of these angles is the adjacent angle To angle 1, yes sir. 4, very good. Adjacent, if you remember, means next to. So 4 would be next to 1. Let's just go back in time again. What kind of an angle does 4 and 1 create? Supplementary, right? Which equals 180 degrees, right? So if I said this is a blank pair, what kind would this be? This is a blank pair. No, not a supplementary pair. It doesn't exist. 1 and 4 create a supplementary angle, yes. But it's known as a linear pair, guys. We talked about this probably, I don't know, chapter 1 or 2. A linear pair. Why is it called a linear pair? Because it forms a straight line. And a straight line is linear. Make sense? All of these vocabulary terms must be ingrained in your brain. So the exterior angle, gentlemen, is an angle which is both adjacent and supplementary to an interior angle. It has to be angle 1 because angle 1 is adjacent to angle 4 and it's also supplementary to angle 4. So the angle that is both adjacent and supplementary to an interior angle is the exterior angle. Okay? Now, let's say that I got rid of this. Hold on. Let's do this. Let's ungroup it and just play around with it a little bit. Let's say that instead of there, let's say I had it here. The exterior would be 1 here, right? Because it's adjacent to the 2 and it's also supplementary to the 2. Who would be the remote interior angles here in this case? 3 and 4. Very good. Okay. All right. The remote interior, yes, sir. You could have 2 exterior angles, sure. You could have this one, let's call this 5, and then let's call this 6. The remote interior angles would depend on who you're using as the exterior. If you're using angle 5 as the exterior, great question, by the way, 3 and 4 would be your remotes. You with me, my brother? If you were using 6 as the exterior, 2 and 4 would be the remotes from that particular exterior angle. Does that make sense, my man? Thank you very much. It's a very good question, actually. Very proud of you. Good man. So the remote interior angles, that's the angle, the interior angle of a triangle, which, and I should have said, those are the interior angles, sorry, of the triangle, which are not adjacent to the exterior angle. So this technically should be remote interior angles, and this is these are, I should say, the interior angles of a triangle, which are not adjacent to the exterior angle. That's my bad. I apologize. Okay. And the exterior angle theorem now. Does anyone remember the exterior angle theorem? I know we didn't do a lot of homework on this, I know. And we didn't do a lot of proof on this, I know. I had told you this one day, I forget what lesson, and I said, guys, this is used a lot on the SAT. Does anyone want to take a gander at it? Yes, sir? Uh-huh. No. Close. Remember, think about that statement, though. If you take the exterior angle and you subtract 180 from it, you get angle 4 because they're supplementary. Okay, that's easy. That's supplementary angles. The exterior angle theorem states the following, guys. The measure of the exterior angle of a triangle is equal to the sum of the remote interior angles of the triangle. Okay? And that's really, really important. Now, you may say to yourself, but why? I can just subtract 180, Moral. This makes no sense. This is stupid. No, it's not. If I told you that this was 30 and this was 48, and I say find angle 1. You could do this two ways. You could do this two ways. You could go 180 minus 30 minus 48, find angle 4. Take 180 minus angle 4 and then find angle 1. You can do that. There's nothing wrong with that. There's nothing mathematically illegal about that. No worries. However, it's time consuming. That's why when I did teach it, I said this is really good for the SAT. Angle 1 equals 78. Done. 2 seconds. Bye-bye. Have a good day. The exterior angle will equal the sum of the remote interior angles always. Always. Okay? Now, sometimes they're going to give it to you very easy. Sometimes they'll give you a very easy situation. For example, let's say I give you a triangle, right? And I have an exterior angle here, and I say that this is whatever, just for speed's sake. And I say find the exterior angle. That's ridiculous. X is going to be 120 degrees. I get it. That's Mickey Mouse. 180 minus 60. Easy. Woo, no big deal. However, again, if I don't give you that, and I say to you, whatever, this is 42, and this is 70, and I want to find angle X, what's the answer? Exactly. Angle X will equal 112 degrees. Again, could you go the long way if you forget this? Yes. 180 minus 42 minus 70 will give you this angle right here. Then 180 minus this angle right here will give you angle X. But that's just too much time. Too much time, in my opinion. In my opinion. Okay? Does that make sense? May I continue, gentlemen? Thank you, gentlemen. Okay. Now, the midsegment or midline theorem. This is a very important theorem. You see this a lot on the SAT as well, believe it or not. And the theorem states the following, gentlemen. A segment joining the midpoints of two sides of a triangle is parallel to the third side of the triangle and is half of the length of that third side. So a segment joining the midpoints of two sides of a triangle is parallel to the third side of the triangle and is half of the length of that third side. What does this look like? It looks like this. So you have D is the midpoint of AB. E is the midpoint of EC. You can tell that by the tick marks. The midsegment theorem states the following. If I connect D and E, which are the midpoints of two sides of this triangle, this automatically makes DE parallel to the third side BC, and DE will be half of the size of BC. So in this particular case, if I tell you that BC is 20, DE is 10. Always. Always. And it works for any triangle at all. Let's say that I have a triangle. Let's look at it from a different perspective, okay? Let's say that I have this triangle here like this. Okay? And let's just call this A, B, and C. Let's say that D is the midpoint of AB. What's wrong with me? D is the midpoint of AB, and let's say that E is the midpoint of AE. AC, rather. If I connect DE, DE is connecting. It's a segment that connects the midpoints of two sides, that automatically makes DE parallel to BC. And let's say BC is, I don't know, 25. DE would be 12.5. It will be half the size of that third side. So you can rotate this in any way possible. Does that make sense, gentlemen? Yes, sir, my brother. There are no exceptions as long as, my brother, you're connecting the segment that connects the midpoints of the two other sides. If these are not midpoints, oh, you can't do anything. And actually, yeah, I'd have to label this. If on a test or on a quiz or something you saw this, and I tell you, does x equal 40? With the markings that I have there, would that be true? No. Because do I know that these 2 points here are midpoints? No. However, if I give you these markings, is that true? Yes, 100% of the time. 100% of the time. And guess what else happens here, guys? Check this out. If this is parallel to this, won't this angle be congruent to that angle? Because of the corresponding. Same side interior means that the sum is 180, Papa. Okay? No worries, brother. You're human. This would be corresponding. And guess what? This angle would be congruent to this angle also because of corresponding. So it's very powerful. There's a lot of stuff going on there. Great questions. Does that make sense, my brothers? May I continue, gentlemen? Okay. Let us continue then. That's it for new knowledge. Now let's see how this works. Okay? Okay. So I've got here, for example, one, the given is the diagram. I want to find x, y, and z. I want you to kind of go back in time when we had overlapping triangles. And I want you to separate them. Thank you. Okay? Think about this. We've got 3 triangles here, right? Let's go ahead and solve y first. If I isolate this red triangle, how would you find y nice and easy, even though it looks super complicated? Yes, sir, my brother. And then, right, subtract it from 180, right? So what you would do is y is 180 minus 85 plus 55, so minus 135. So y would be 45 degrees. Does that make sense, gentlemen? What theorem are we using here? The triangle sum theorem. Every single triangle has an interior sum of 180. Now if we separate the other triangle here in blue, who would I be trying to solve here with this blue outline? And how do you think you would find x here, my brothers? 180 minus the sum of 160. So that would be x equals 180 minus 160. X would be 20 degrees. Yes, sir. Are you sure, my man? That's what I'm here for, dude. Questions. That's how we learn. I'm very proud of the questions so far. Great questions today. Yes, sir, my brother. Excuse me. Okay, no. No. And that's a great question. I thank you so much. Angle 55 is this right here, my brother. Right? So, okay, let me see if I can do this better. Hold on. Let me see something. Let's go ahead and isolate this. If I take this here, okay, you see how 55 is the corner, not this, right? Do you see what I'm saying? Making it a little bit bigger. They're not adjacent. Angle 55 is not adjacent to angle X. You feel me? Hold on. Let me do this again, but let me mark it first correctly. You sure, my man? Okay, so yeah, so basically what I'm saying is 55 is here. Adjacent to X would have to be here. And that's not what 55 is. You feel me? Promise? Okay. Now, how would I find angle Z here, gentlemen? Yes, sir, my brother. Phenomenal. 180 minus the sum of 20 and 45. So Z would be 180 minus 65. Z would equal 115. That would be this triangle right in here. And that would be 115. Fantastic. Excellent job. Excellent job. Excellent, excellent, excellent. Pretty simple, right? That was pretty cool with a little zoom in, wasn't it? Yeah. I was hoping to use that one day with you guys. All right. But does that make sense? Okay. May I continue? Thank you. Okay, example 2. The measure of the three angles of a triangle are in the ratio. No. In the ratio. My bad, sorry. No excuse. In the ratio 3 to 4 to 5. Find the measure of the largest angle. We've done these types before. What do we do when we have a ratio here, my brother? Thank you. We know that the ratio, okay, of angles is 3 to 4 to 5. But we don't know the value of any of these angles, correct? So this would be 3x, one of them would be 4x, and the other one would be 5x, right? So 3x plus 4x plus 5x has to equal 180 degrees. 7 plus 5 is 12x equals 180 divided by 12. And I believe that would be 60 degrees, correct? Or 75? Now I'm pretty sure it's, I'm sorry. Wow. Wow, that was an epic fail on my part. I'm pretty sure it was 15. I was, sorry, my math, I was doing math and I messed it up because I said 12 goes into 18 one time, there's 60 left over. And that's the answer I put. Don't be like me. Be sharper than me. I apologize. So find the measure of the largest angle, though. Which should the largest angle be? 5 times 15, and that's where you guys got 75. So you see, we were both not really focusing. I was using one calculation. You guys were already using another one, step by step, though. Pretty simple, no? We know this already. Whenever they have these ratio ones, 3x plus 4x plus 5x equals blam, whatever it's supposed to. May I continue? Okay. This is a good one. If one of the angles of a triangle is 80 degrees, find the measure of the angle formed by the bisector of the other two angles. Okay? This is a good one. And here you're going to have to set up a system of equations. Come again? 25. You're just coming up with that without any work at all? It's just, it came to you? Like a vision? Okay, how? How would it be 25? You're wrong, but how would it be 25? Why would you assume that those were congruent, Papa? Okay. Let's think about it like this. This is one whole triangle, correct, my brothers? Yeah, you cannot assume. No one said that AB and AC are congruent. No one said the triangle ABC are isosceles. So that's where your error came. But at least you're thinking. I'm proud of you. Okay? However, what do we know about the full angle triangle ABC? Doesn't angle B, isn't angle B really 2x? Isn't angle C really 2y? So doesn't 2x plus 2y plus 80 equal 180? So then doesn't 2x plus 2y equal 100? If I divide 2 to both sides, my brothers, doesn't x plus y equal 50? You with me so far there? Because this is where I'm going to throw you a curveball. So if x plus y equals 50, okay? Now let's look at triangle DBC. Isn't the interior angle isn't the total sum of the triangle DBC angle x plus angle y plus angle BDC? Doesn't that have to equal 180? But my brothers, what does x plus y equal? So this is 50 plus angle BDC equals 180. Subtract 50 to both sides. So angle BDC equals 130. You feel me here? Come again? That's pretty good, right? Yes, sir, my brother. Okay, thank you, my brother. Okay, let's first look at the problem here from the beginning. If one of the angles in a triangle is 80, find the measure of the angle formed by the bisectors of the other two angles. First of all, we're not looking for x and y, are we? We're looking for the angle formed by the bisectors. So the angle formed by the bisectors is this angle BDC, correct? We understood how to do this blue part. Awesome. So from here, my man, once we know that x plus y equals 50, here in red, isn't this triangle composed of angle x plus angle y plus angle BDC, my brother? That's okay. That's why you asked. Thank you. And then isn't x plus y, don't we know that that equals 50? So then we have 50 plus that angle formed by the bisectors, which is angle BDC, equals 180. Subtract the 50. Angle BDC equals 130. Yes, sir. Okay, what's x plus x, Papa? What's x plus x? 2x. Isn't that angle B of triangle ABC? Okay, where I got the 100. Thank you. I subtracted 80 to both sides. Don't want to apologize. Thank you for caring. Thank you. This is a great question. This is an SAT kind of question, for sure. Okay? I think some of you, I just blew your mind. Okay? Does that make sense, gentlemen? May I continue for the last one? Thank you, gentlemen. Last but not least, brothers, angle 1 equals 150 degrees. Cool. Angle D is the measure of angle D is twice the measure of angle E. So what do we know nothing about here? Yes, sir. No, we know something about angle D. What do we know nothing about? What is angle E then when we know nothing about X? What do we know about angle D, my brother? Aha. What do we know using the exterior angle sum theorem? 3x equals 150. Divided by 3, x equals 50, correct? Right? So find the measure of each angle. So angle DEF equals 50, correct? And angle EDF equals, 100. Now, I heard someone say 30 before. 30 is angle DFE. That's not what they're looking for, my brother. Well, yes, they are. If I learn how to read, this is 30. You could have done that one right off the bat, 150 minus 180. Or 180 minus 150. Yes, sir. DEF. Wow. Epic fail. How can I have 250 degrees in a triangle? Thank you, my brother. No excuses. Thank you. Maybe I should learn how to pay attention. Does that make sense, my brothers? Alrighty. Thank you. Let's go ahead and start our homework then together. Thank you very much for a great lesson. I hope you learned a lot. God bless you and have a great day.